Thank you for the introduction. So thank you for the opportunity to share with the DFX Insights attendees and the community of customers that are deploying DFM Pro and the DFX platform. Thank you for this opportunity. It's greatly appreciated. So I'm going to talk a little bit about Honeywell Federal Manufacturing and Technologies with regard to how we see DFM Pro being a valuable tool to employ in our design processes, mainly with respect to understanding how we can bring manufacturing information into the decision-making process, design decision-making process much earlier in the development phases, early in the early stages of development. So I'll get into that. All right, so just a little bit about myself. I'm a senior engineering project analyst on our DPRE team. DPRE stands for Digital Product Realization Enterprise, or also known as our model-based enterprise team, where I'm primarily involved in research and development of technology tools to support the model-based enterprise. And my main focus area is in the manufacturing area. How can MBE solutions help to support and enhance manufacturing activities, mainly focused on the downstream areas of the model-based enterprise and product development. I'm also involved in road mapping and adoption strategies for the model-based enterprise at our site. And I'm the principal investigator or project lead for DFM analysis automation at Honeywell FM&T. So I'll begin by providing some context around who we are and what we do at Honeywell FM&T. We manage and operate the Kansas City National Security Campus as a part of the NNSA Nuclear Security Enterprise, or the NSE. The NSE is comprised of national laboratories, production plants, and test sites involved in the design, production, and testing of nuclear weapons and nuclear weapon components. At the Kansas City National Security Campus, we are a multi-mission engineering and manufacturing enterprise delivering trusted national security products and government services. As a Department of Energy contractor, we, Honeywell FM&T, manage and operate the KCNSC with approximately 5,500 employees and a $1.6 billion annual federal budget. So the mission at the KCNSC is to support national security objectives by providing exceptional solutions, managed operations, and targeted services through talented people. Our NNSA mission priorities include providing and sustaining a safe, secure, and effective deterrent, strengthening science, technology, engineering through continuous research and development and capability maturation efforts, modernizing our infrastructure, and reducing global threats and strengthening the national security enterprise. Coherent actions such as smart business intelligence, key partnerships, early stage collaboration, and innovation technology are implemented to effectively and responsibly steward the national nuclear stockpile. And so as we think about or focus on our product realization goals at Honeywell in executing and delivering on our mission, these are the goals that we are driving, our efforts that are driving to realize. Firstly, to increase the quality of new products during the development period. Secondly, we want to shorten the development cycle time, including the time of design and manufacturing process planning. And thirdly, we want to decrease the cost, including the cost of design, manufacturing, production, scrap, and delivery. And as I move a little further in my presentation here, I'll address the scrap goals in a little bit more detail. And so we believe that we can achieve these goals by enabling and maturing an automated design for manufacturability capability, DFM Pro, and integrating this capability into our design processes and workflows so that we can increase the product quality, so that we can shorten development cycle time, and so that we definitely want to increase product quality and to decrease the cost of design, manufacturing, production, scrap, and delivery. Ultimately, to achieve these goals, we want to improve concurrent engineering. DFM Pro is the technology tool to support these efforts, but it really comes down to design collaboration that pulls in material science data, tooling strategy, assembly strategy, manufacturing, scientific analysis, other resources into the beginning stages of the design and product lifecycle. That's really our focus. DFM Pro is a technology tool to help us do that. But by capturing and incorporating all of this data and expertise in the form of DFM rules that are reflective of our manufacturing capability parameters, we believe that we can improve design collaboration and concurrent engineering practices. So in kind of getting into our journey towards DFM analysis automation, we began with vetting various tools to support DFM analysis. A down selection of the best suited analysis tool for the KCNSC was made based on certain defined criteria that we set, and DFM Pro proved to demonstrate most effectively the type of things that we were concerned with and the capabilities that we felt would best support our needs to understand manufacturability and to validate our product design. In year two, we focused in on really exploring the tool's functionality, usability, configurability, and we actually demonstrated a rule customization proof of concept that incorporated our whole tolerance guide from our machine parts DFM guide into the DFM Pro tool. So we were very excited to understand and to see how we can actually enhance DFM Pro in our organization beyond just simply configuration of the out-of-the-box rules to reflect our capability, but really excited about the customization ability where we can actually create and develop new rules so that we can more effectively incorporate our DFM guides and information into the tool. In year three, we involved deeper dive into the rule customization to incorporate our internal DFM standards and to really go after and really leverage product and manufacturing, PMI, and GD&T annotations on the 3D CAD model. As I mentioned a little bit earlier, with respect to the model-based enterprise, we really have a concerted effort right now to leverage the benefits of model-based definition. And so the customization rules that we went after were really focused in on how we can leverage model-based definition, the PMI and the GDT annotations associated with the surfaces and features in the CAD model, we really focused in on how we could take advantage of that. So enabling this capability in our environment really began with focusing in on converting. We have 40 plus DFM guide documents, human readable PDF format. And so our journey is in deploying this tool is really focused in on converting these 40 plus DFM guides into digital information that will be maintained in the rule manager or the rule database with input from our manufacturing process experts. And then, of course, the digital information would then be used to validate the designs for manufacturability within CAD environment. As I mentioned a little bit earlier about the rule customization efforts, displayed here, you see a list of those rules developed from requirements defined by our manufacturing process subject matter experts. And so in addition to the 36 out-of-the-box rules for machining processes, we're now also able to validate our design, for example, based upon material grade density properties. We can also validate profile tolerances as well as orientation like perpendicularity and form tolerances such as flatness and cylindricity, as well as validate maximum thread depth for drilled hole features. And I believe these rules that we've developed have now been incorporated into the later versions of DFM Pro now as a part of the out-of-the-box rule set. We understand and believe that, Honeywell FM&T is not the only organization that is driving towards leveraging model-based definition. And so we're glad to contribute towards all of our goals in really trying to understand the tolerancing schemes and other PMI and information that affect product realization. And so as a case study, we ran a DFM analysis on an actual part, which was a pretty complex design. It consisted of 8 pages, 6 datums, 37 different views, 17 unique surfaces, 37 drawing dimensions, 9 flag notes, over 100 CMM inspection keys, and a partridge in a pear tree. It was a pretty complex design, a lot combed through. And to note, the part also had 4 crucial features that consistently failed CMM and 21 features with historical CMM failures. The DFM Pro DFM analysis tool, executed a full evaluation and identification of the design issues in this part in less than 2 minutes. This was very exciting and very impressive from our point of view with respect to this particular part, this particular component, just based on the complexity of the design and all that was involved, all the features and all the issues with it, that DFM Pro was able to identify and expose where the issues are in less than 2 minutes versus months of engineering work that have gone into realizing this part. And so this allows us and significantly accelerates our ability to provide manufacturability assessment and design feedback to our design agency counterparts. You recall earlier in the presentation that we have multiple sites across the United States. We ourselves at Kansas City are a production agency, and we collaborate with several design laboratory agencies to realize parts. And so there's a lot involved with the handoff of information and attempting to collaborate and provide feedback with regard to design decisions, with regard to manufacturing capability. And we see that this tool, this capability with DFM Pro will significantly improve that process. So we have charted a path forward for deployment DFM Pro with a phased approach. We began with the machine parts, machining processes, our standards around that. Really went in and configured those rules to reflect our capability, develop those 10 rules to supplement the manufacturing rule set, really trying to leverage model-based definition, the PMI, product and manufacturing information, GD&T information in the model. We really had a concerted effort, really focusing in on that initially. Moving forward, we plan on, or we're actually engaged in expanding our rule set, our configuration efforts, and our customization efforts to focus in on additive manufacturing and our material science data. I have engaged in some conversations with some of the HCL folks with regard to the possibility of actually integrating Granta, the material science database, if it's possible to actually integrate that with DFM Pro. So as we populate and manage our material science data in Granta, how can we integrate that and tie that into DFM Pro to support the analysis with regard to material selection? So that's something that we are focused in on right now, in addition to configuration and customization of our additive manufacturing processes. We're also really focused in right now on our tool design team, deployment in tool design. So as I mentioned, we are a production agency. However, with tool design, we have the opportunity to actually influence the realization of tooling and fixturing from concept all the way to fabrication. With actual product to support the NSE, we're more on the downstream, and we receive that information from our design agency partners. But we really wanted to understand more so in our environment the use of DFM Pro throughout the whole life cycle of a product, in this case, tooling. So we're really focused in on our tool design processes and really wanting to explore and deploy this tool and capability in that environment. We've actually gone in and configured a rule set for our tool design. After exercising the tool a little bit, understanding the findings, the tool designers being able to provide some feedback and some thoughts on the analysis results that they're getting, maybe fine-tuning some rules and what have you. Next steps would then would involve some customization of rules for the tool design environment. Our future exploration and enablement will involve usability testing in our test equipment design segment. In addition to tool design, we also have our test equipment design group, and they're involved in the design development of testers for our product. And so we have begun conversations and starting to look at the as-is process versus a future process where we can insert the use of DFM Pro to validate and support our test equipment designs. We also plan to integrate DFM Pro with our Windchill PDM system. to establish that single source of truth for our rule files and analysis results. We're in the process of setting up a WT part structure such that we can link and associate all of our analysis results to the product structure so that everywhere the product goes, the analysis results will hitch a ride and go with it. And so we're really excited and looking forward to establishing those windshield workflows to support our design process and to configuration manage that information to support that process. We're also looking at how DFM Pro can support make versus buy decisions as we validate, analyze our product designs based on rule sets that reflect our capability in-house versus rule sets that reflect our suppliers and other vendors to produce parts for us. Being able to leverage DFM Pro analyses and make some comparative approaches to understand, if it's more efficacious for us to make this part in-house or if we should form it out to a third party. So we're wanting to explore how DFM Pro can help to support those make versus buy decisions. And then one of the last things that I'll touch here in this presentation is the DFX Analytics add-on module to DFM Pro. We are currently kicking off an evaluation project to really get into DFX Analytics. We see great value in the DFX Analytics tool in being able to capture metrics with regard to product analysis, validation, what types of issues are we consistently seeing, what types of products are we seeing these consistent issues, understanding the usability, whether or not DFM Pro is being employed and applied to all of our designs and when it was applied in the process, and being able to visualize and capture that in various presentation states, report out, so that we can really understand the effectivity of DFM Pro in our organization.